Hello students, today we will continue our topic, that is equilibrium, and we will start from basic only, and we will be covering this topic by taking some questions. Some questions will be direct from NCERT and some question related to numerical. So the first question it is given, which of the following statement is incorrect? In equilibrium mixture of ice water kept in perfectly insulated flask, mass of ice and water flask, then mass of ice and water does not change with time. And if you see, they have said that it is insulated. So as it is insulated, so there will be no heat exchange will be taking place, and temperature inside that insulated flask will be constant. So that is why it will be under some equilibrium. So mass of these, they will not be changing, and it is one statement from NCERT. The second, they are saying intensity of red color increases when oxalic acid is added to a solution containing iron nitrate and potassium thiocyanate. If you remember, Fe plus 3, when it reacts with thiocyanate, then it forms Fe SCN, and this gives us red color. So if you add anything which decreases this or this, then that will drive the equilibrium in the backward direction. So this question, this statement B, it is directly from the NCERT related to Le-Chatelier's principle. So when you add oxalic acid it reacts with oxalate ion and forms complex. So as concentration of Fe will decrease, this equilibrium will shift into backward direction, and the color is coming due to this. As concentration of this A salt, it is decreasing, so intensity of this red color will also decrease. And they have given also one thing, that if you take Hg and then Hg plus 2, it reacts with SCN minus to form a complex. So this is B complex, let's say it will form a C complex. Then also intensity of this red color will decrease. It will not increase, it will decrease. Okay. So as we are adding something which will be removing the reactant, as concentration of reactant is decreasing, this equilibrium will shift into backward direction. Now the C statement. On addition of catalyst, the equilibrium constant value is not affected. We have already seen in the chemical equilibrium topic that K equilibrium, it is a constant and it changes only with temperature. So on addition of catalyst, on addition of substance, decreasing volume, pressure, addition of inert gas, it will not be affected. Equilibrium constant, any type of equilibrium constant, solubility product, or it can be dissociation constant, acid dissociation constant, base dissociation constant, hydrolysis constant, all those constants, they will not change. This is not rate constant, it is equilibrium constant, mind it. Then D, it says equilibrium constant of a reaction with negative delta H value decreases as the temperature increases. We have discussed that if delta H is less than 0, if you increase temperature, value of K equilibrium will decrease, hence reaction will go in backward direction. If this is endothermic, then on increasing temperature, this value of K equilibrium will increase and reaction will go in forward direction. So considering that, they are asking incorrect statement. In the exam, you need to mark it incorrect, and also while bubbling the circle, you just see whether they are asking incorrect or correct. So it is B answer. Now moving to next question. The pH of neutral water is at 25 degrees Celsius 7. As the temperature increases, ionization of water increase. Because this reaction is, or you take H plus aqueous along with OH minus, this is again endothermic reaction. So if you increase temperature, its K equilibrium will increase, that is Kw will increase. As Kw will increase, the product, that is hydronium ion as well as OH minus ion, both will increase. If H plus is increasing, so pH is minus log of H plus. So it means this pH will decrease. Similarly, what is pOH? Minus log OH minus. as OH minus is also increasing, so definitely pOH will increase, and summation of pH and pOH, that is pKw, definitely all three things will decrease. It doesn't mean that solution will be becoming acidic, because still concentration of H plus and OH minus is same. So in this question, if they are saying if it is increases, then what will be the pH of pure water? pH of pure water, because pH is now decreasing, earlier it was 7 at 25 degrees Celsius, now it will decrease and it will be less than 7. It doesn't mean solution or water, pure water will become acidic. It is still neutral, very important. If there is pure water, neutral water, on increasing temperature, you cannot make a solution acidic or basic. Fine. So moving to next question. If K values are given, okay, so on the basis of K value for any acid HA, we write like this, and K, this is C minus C alpha, very important, it has to be C alpha. This is C alpha and again C alpha. So Ka can be written as C alpha square by 1 minus alpha. So it clearly says if Ka value is high, then definitely this alpha value will be high. And by approximation also we say that for weak acid 1 minus alpha can be taken as 1. So we can write alpha is root Ka by C. Okay. So if Ka value is high, this alpha will be high, and similarly we can also write C alpha as root Ka into C. So for given concentration, H plus will be more. So Ka high, if K value is high, then Pk value will be low, and acidic, stronger acid. Similarly, if Kv value is high, Pkv value will be less, and it will be stronger base. Okay. So they have given already values of Ka for acidic acid, that this is for hypochlorite acid, and so highest value is for formic acid. So formic acid is the most acidic, then acetic acid, so answer will be D. And regarding if they ask pK value, then trend will be just reverse. What is pK? pK is negative log of Ka. Fine. Moving to next question. Acidity of VF3 can be explained on the basis of which of the following? We have already discussed in the previous session that acid which gives H plus, and then they will be known as RE-NEET acid. If acid which donates proton, we will call them as Bronsted acid. Acid which can accept pair of electron, they will be called as Lewis acid. So BF3, we already know BF3 is having vacant orbital, its hybridization is sp2, it will be having vacant p orbital, so it can accept pair of electron. As it can accept pair of electron, so it can be said Lewis acid, because also you see that it is not having any proton which can be donated, so it is Lewis concept. Lewis is the most broader concept among all. Now regarding conjugate base acid, HCl and H2O, if such equilibrium is forming, then species which donates H plus, it will be known as acid, which takes H plus, it will be known as base. Conjugate part of base, as it is taking H plus, this will be known as conjugate acid, and it is taking H plus, it is giving H plus, so this will be known as conjugate base. A given acid will become conjugate base after donating the H plus. If you in the given acid, if you remove H plus, it will become conjugate base. If you in the given compound, if you add H plus, it will become conjugate acid. Fine. So which of the following is amphiprotic? So amphiprotic is an acid which can take as well as donate H plus. So these very important three acids, H3PO4 phosphoric acid, so it has 3 H plus. This is tribasic acid. We already know by structure. So hydrogen which are attached to oxygen, they can be donated. In case of H3PO3, there are only 2 OH. In case of H3PO2, I have taken this question because these acids are very important, and every other year you will get question on the basis of these 3 acids. Phosphoric acid, this is phosphonic acid, this is phosphenic acid. Phosphonic. Also this is known as phosphorus acid. This is hypophosphorus acid. This is phenic and also known as hypophosphorus. So this is tribasic, dibasic, and it is monobasic. So if it gives 1 H, it can give only 1 H plus. So this cannot be. This is conjugate base of, this is coming from H3PO2, which is monoacidic. It cannot further give. And it is coming from H3PO2, H3PO3. It has also given all 2 acids. So this is the only which can give. It is still having. It is coming from phosphoric acid. So it can act as amphiprotic. It can take as well as any species which is having negative charge. It can take H plus. But H plus will be donated only when they are attached with OH, oxygen. Conjugate acid of the CH3COH. I have already told you, any substance is given, you just take H plus, then it will become conjugate acid. If you donate H plus, the remaining species will be called as conjugate base. So for this, they are asking acid. So to become acid, you need to take H plus. Okay. So moving to next, which of the following has maximum pH? Again, if some acids are given and they are asking which is stronger. So in organic chemistry we study it in detail, but the important thing is that whenever they are asking, you need to check stability of A minus. The most important factor is size. So whenever the acids are given and all of them belongs to same group, then you check size of conjugate base. If X acids are given, you remove H and now check the size of the conjugate base. So size is larger, then that will be better acid. So it is the stability and acidic, HF, then HCl, then HBr, then HI. This is regarding stability. If conjugate base is stable, so for acid, acidic strength, it depends on stability of conjugate base. So if conjugate base is stable, and it will depend on size. First prime factor is size. So this is acidic nature, acidic strength. Now if size are same, or you can say if all of them given acid they belongs to same row, then we will check electronegativity. So electronegativity, higher the electronegativity, it will make the stability of A minus will be more. But this factor will be in this, if you see, first we need to take size. Size is important factor for us. Then electronegativity. So if you check among NH3, H2O and HF, HF is more acidic because its conjugate base will be more electronegative. So in these cases also, all of them belongs to same group. They belongs to same group, 16 group. So down the group size will increase. So most acidic will be H2TE because its conjugate base will be more stable. Also it can be explained on the basis of bond strength. Down the group, the bond strength will become weaker, so H can be released easily. Okay, so it will give highest number of H plus ion. Now coming to the next very important point. Okay, before this, you see, sometimes people confuse that water is more acidic than phenol. They think that pK of water is 7. No, pK of water is not 7. pH of water is 7 at 25 degrees Celsius. However, phenol is more acidic than water. Its pK is 10. However, water का जो pK है for water is less acidic than this, and also it can be judged on the basis of stability of conjugate base. Its pK or ionization constant, if you see, it will be around 15, around 15, or its pKw is 14. So that is the thing. pH is 7 at 25 degrees Celsius. So water is even more acidic. Water is more acidic than alcohol. So you should mind this point. Now pH of 10 raised to minus 10 HCl. See this formula, it is not, it does not say this H plus is coming from acid. It does not mean. However, in most of the problem, if I take this H plus coming from acid, this is okay. This gives us a right answer. But this H plus means in this formula, H plus present in solution, total H plus present in solution. If a solution is having 3 substance, 4 substance, including solvent also. So this is total number of H plus. It is total H plus. In most of the cases, if you are adding acid, then majority of H plus ion will be coming from acid only. So we directly take H plus due to acid and we put it over here. But these H plus are H plus due to acid as well as H plus due to water. But usually H plus coming from water are ignored because they are very less. But if H plus coming from acid, they are not contributing, or we can say whenever this H plus coming from, we already see from minus 10 minus 1 to 10 minus 6, pH will vary from 1 to 6. This is okay. If H plus due to acid, H plus, if in the problem it is said that H plus due to acid is 10, H plus due to acid is in this range, then pH will be varying from 1 to 6. But if it is 10 raised to minus 7, then pH will comes around 6.79. If it is 10 power minus 8, it comes at 6.97 or 98 as options are given. If H plus due to acid are 10 raised to minus 7 minus 8, if they are less than 10 raised to minus 8, then pH is tending to 7. Very important. If you apply direct formula and you say that pH is coming as 10, logically if you think this is wrong. On adding acid into water, how can it become basic? If you are adding acid into water, how can it become acid? Okay, how can it become basic? So by logic also, if you see, if you are adding 1 drop of acid, it might not change pH. If it is already 7, it will be close to 7. Okay, so the answer will be 7 only. By adding acid, solution will be acidic. By adding base, solution will be basic. Okay. So please check this. Also, if it is same is given for water, if OH minus due to base, if they are 10 raised to minus 1 to 10 raised to minus 6, then pH will vary from 1 to 6. If it is 10 raised to minus 7, then pH will be 6.79. Similarly, if it is minus 8, 6.97 or 6.798. If it is less than 10 raised to minus 8, then pH will be close to 7. Clear? One of the favorite question for Ionic. Okay. Now moving to next. What is the hydronium ion concentration 0.25 HA solution? Very simple. Considering the same thing, Ka will be C alpha square by 1 minus alpha. By default we will take 1 minus alpha as 1. So again alpha will be root Ka by C. So if we apply over here, or we can also do that H plus will be C alpha, that is root Ka into C. Directly apply. Ka value is 0.25, sorry, C value is 0.25 and K is 4 into 10 raised to minus 8. So it will be nothing but 10 raised to minus 4. H plus is coming as 10 raised to minus 4. So pH will be 4. So pH will be 4, however H plus is 10 raised to minus 4. So, but for such question you can also check value of alpha. This alpha should be less than 0.1. It should not be greater than 0.1. Otherwise this assumption is true only when alpha is taken less than 0.1 for NEET aspirants. Okay. So either you can do directly. If degree of ionization is 0.0 alpha, then what will be the pK value? Decimolar means 0.1 molar. So again, if you take alpha is root Ka by C, So Ka is unknown for us, so alpha is square, C alpha, this is Ka. This is another very important thing. Sometimes we see that if alpha will increase, then K will also increase. No, if alpha will increase, the alpha will be changing with respect to concentration only. This product of concentration alpha square will always be constant at given temperature. It is a constant at given temperature. So do not get into the trap that if alpha increases, then Ka will increase. If alpha is increasing, it means concentration is decreasing. That is how the product of C and alpha in this expression it will be Ka. So we can, at given temperature, we can also write C alpha, C1 alpha 1 square, C2 alpha 2 square, it is Ka. Very important. So from here, if you put the value 0.01 and 0.1, so it will be 10 raised to minus 6, 10 raised to minus 5, that is your K. Pk, if you take log, it will become 5. Very important that if now till now we have taken only monobasic acid, this is diprotic acid. So in diprotic acid, if only diprotic acid is given, only diprotic acid is present, let us say H2A in solution. So H plus will be coming from the first step. Diprotic acid, weak diprotic acid, it will be dissociating in 2 steps, like this, okay, in stepwise manner. So for this Ka1, it will be H plus into Ha minus and Ha, or we can use simple directly whatever we have written, C alpha square upon 1 minus alpha from there. Second step will be Ha minus gives H plus and A minus 2. So Ka2 will be H plus and A minus 2 divided by Ha. So as common N effect is operating, we can consider that H plus coming from the remaining steps other than first. They can be ignored. Okay. So in this case, we will consider whatever H plus is coming from this part. Okay. So in this case, Ka1 is given and concentration is also given. So from Ka1, we can write 4.0 into 10 raised to minus 7, then H plus and Ha minus both will be same, so it will come as C alpha square 1 minus alpha, or you can write 10 raised to minus 7, C is your 0.25 into alpha square. This can be ignored. This is 4 by 25 into 10 raised to minus minus 4. Okay. So this alpha will become 2 by 5 into 10 raised to minus 2. This is alpha square. This is your alpha. And that is nothing but 0.004. Alpha is this. Okay. If you take 0.4 and then again to alpha, it will be this. So H plus from here, this is C alpha, so it will come as H plus H, again 0.025 into 10 raised to, this is 0.004. So this is your alpha, H plus. Now in the second step, you know concentration of this is C alpha, this is also C alpha. So in this case, they will get cancelled out. Even you do not require to solve the first step. I have solved it just to show you what will be the concentration of H plus. If they ask what will be the concentration of H plus, then you can ignore second step completely. H plus will be coming from the first step only. So the normal calculation, you will get H plus from here. However, if they are asking A minus 2, that is they are asking carbonate ion. So for carbonate ion, you can take this thing. In the second step, the concentration of H plus and Ha minus, these two things, it will be same, because we are not considering any contribution of H plus from the second step. So this Ka2 will come as A minus 2. You don't have to solve. If only diprotic acid is present, if only diprotic acid is present in the solution, then always for this carbonate ion it is nothing but Ku2. The second conjugate base or conjugate base of Ha minus, it will be just equal to K2. So in this case only this is your answer, D. pH of this nicotine is this can be solved. If pH is given, we can calculate pOH. What will be pOH? है ना, निकोटीन को हम लोग बेस के जैसे लेते हैं. So pOH will be 4.3. So OH minus will be, it is 10 raised to minus 4.3. So it can be written as 10 raised to minus 5 into 10 raised to 0.7. And 10 raised to 0.7 is nothing but this 0.7 is log 5. So it will be 5 into 10 raised to minus 5. This is your OH minus. If you know OH minus, now only we have seen that OH minus for weak acid also it will be Kb into C. Like acid, which is for mono acid, this is Ka into C, monoprotic acid. For this is for mono basic acidic base, mono basic acidic, and this is mono acidic base. So you just need to solve. Square take, this will come 25, 10 raised to minus 10. C they have already given 4 into 10 raised to minus 3, and now you can calculate Kb. Okay, fine. Moving to the next question. Again, for pure water, pH increases while pOH decreases with rise in temperature. No. With temperature, pH as well as pOH both decreases simultaneously on increasing the temperature. pH decreases by both decreases with rise in temperature. Very good. A beer has pH of this. What is the simple question? So H plus will be, now H plus will be 10 raised to minus 4.3, similar to previous one, 10 raised to minus 0.7, that is 5 into 10 raised to minus 5. Okay, simple question. 10 raised to minus 5 molar NaOH solution is diluted 1000 times. If you dilute it 1000 times, the concentration of NaOH will become 10 raised to minus 8. So OH minus due to base it is 10 raised to minus 8. 2-3 minutes before we have studied that for base, for 10 raised to minus 1 to 10 raised to minus 6, pOH will be varying from 1 to 6. For 10 raised to minus 7 it is 6.79. For 10 raised to minus 8 it is nothing but 6.98 or 6.97. If it is less than 10 raised to minus 8, then it will be 7. So we can say 10 raised to, and they are asking pH, very important. They are not asking pOH. This is written for pH, pOH. So pH will be 14 minus this, so it will be 7.02 or 7.03. That is higher than, so lie between 7 to 8. What is the pH of solution in which this is added with HCl? So in ionic equilibrium, another point, whenever they give you two things, whenever they give two things, always if you are mixing them up, one important thing is, first do not forget to change the volume. If you are adding two things, then volume might change. So you should remember that volume can change. You need to take care of the volume. And also if you are adding two things, then one important fact is that you need to consider that whether reaction is happening between these two or not. And after reaction, whatever is remaining in the container, it is going to decide the pH of the solution. It is going to decide the nature of the solution. Things which are giving at initial point are not going to decide. After the reaction, whatever is remaining in the solution, that is going to decide the pH of or nature of the solution. So there are two things when problems related to mixing. One is volume, check volume, always check volume. Second, after reaction, check reaction, whether reaction is happening or not. Reaction possibility. These two things required. One volume change, other this thing. So they are mixing NaOH with HCl. So NaOH, if you see this M into V, this again M into V. So if you multiply this, this will become 2.5 millimole. And for this, moles are 2 millimole. 2 millimole. So clearly we can see this is limiting reagent. It will finish, and this will give us NaCl and H2O. And after reaction, this will be 5.5 millimole. So after the reaction, there is only NaOH. And if there are strong acid, strong base, they do not show any common ion effect. Okay, if there are only a strong acid, strong bases in the solution. So this NaOH will not have any common ion effect due to NaCl. Okay, so we are having only 0.5 mole. Now concentration of NaOH will become 0.5 millimole divided by total mole, total volume, that is 50. Very important. See, this is milli and this is also milli. So this will become 10 raised to minus 2 molar solution. So POH will become 2 and pH will become 12. So whenever there are problem related to mixing, always consider this change in volume, very important. This is your total volume, total. Moving to the next, which of the following will not show common ion effect on addition of HCl? Already I have said, if a solution is containing strong electrolyte as well as weak electrolyte, then common ion effect always operates on weak electrolyte. It does not operate on strong electrolyte. Okay, so in the presence of ions generated by other electrolyte, the alpha of weak electrolyte decreases due to presence of common ion from another electrolyte. Alpha of weak electrolyte decreases, and this is known as common ion effect. So it is always defined with respect to weak electrolyte only. For strong electrolyte, we are not considering at our level. See, so for strong electrolyte alpha, we take alpha as, if until unless it is given, we take for strong electrolyte alpha as 1. Okay, but for weak electrolyte, in the presence of common ion from another electrolyte, this another electrolyte can be strong or it can be weak electrolyte. So in this case, you see, you are adding HCl and they want that. So in this case, common ion effect will appear because it will also, this is weak electrolyte, this is another weak electrolyte, this is also weak electrolyte, A, B, C all are weak electrolyte. So they will show common ion effect. But H2SO4 being strong electrolyte, that is D option, H2SO4, it will not show any common ion effect. Due to presence of HCl, its alpha will not decrease. Which of the following will produce a buffer solution? For buffer, we already know a buffer solution, it forms, again, buffer solution, they can be given directly or they will be formed by mixing two solutions. So after mixing or in resultant solution, we need to check weak acid with salt of weak acid. Salt of weak acid with strong base. Weak base plus salt of weak base. Then finally, that is simple buffer coming from salt hydrolysis, weak acid plus weak base salt. Salt, it should be salt. So these three gives us buffer solution. So in this case, it is NH4OH and HCl. So you see, after the reaction there has to be one weak. This is itself a salt from weak acid and weak base. So in first case, if you see, which of the following will produce buffer in equal volumes. So as concentration is same, after solution, this A will give us NH4Cl. Only NH4Cl will be present. Only salt is present, and which is salt of weak acid and strong base. So this will not form buffer solution. However, it will go for hydrolysis. Second option, NH4OH and HCl. In this case, this is limiting reagent. Its moles are less, however moles of HCl are high, more for given volume. So after reaction, B will have HCl and NH4Cl. That is, it is a solution of strong acid and salt. This will also not form buffer. In third case will give us NH4OH after reaction and NH4Cl. This is the perfect case. In the fourth case, again it is salt and strong base. It is salt and strong base. This is salt and strong base. Strong acid and strong base, if they are present after reaction, then they cannot form buffer solution. Okay. Now coming to solubility, and we will do more questions on buffer as well, but just coming to solubility, if they are saying in which of the following solvent silver chloride is more stable, here also for solubility we say that solubility of any salt AB, it is defined as A plus and B minus. So this salt, this is aqueous, this is again aqueous. So we take, if A gram is added, then out of A, S, this S it can be expressed in mole per liter or depending on gram per liter also. So this is S, then we will apply over here. This has to be S, and solubility of any salt, it is defined on the basis of this S. Okay. So here stoichiometry is same, so this will also be S. So in this case, solubility of salt is similar as solubility of A plus, and that is also solubility of B minus. But according to Lee-Chatterjee's principle, if you are adding A plus from some other solution, from some other method, then this equilibrium will go in backward direction, and as it will go in backward direction, then this value of S will decrease. As it is going in backward direction, then this value of S will decrease and solubility of salt will decrease. If you add something which takes this A plus, then reaction will move in forward direction to regenerate A plus. Okay. Or if you add something which takes this B minus, then also reaction will move in forward direction. So if you add A plus, if you are adding A plus some other method or B minus, and adding A plus and B minus, it will move reaction into backward direction, and that will lead to lowering of the solubility of the salt. So in this case, for silver chloride, we need to check for silver chloride. If you are checking for silver chloride, so in this A, Ag plus is coming from AgNO3. So it will decrease the solubility of AgCl. It will decrease the solubility of AgCl. In second case, Cl minus is coming. In first case, Ag plus was coming. In this case, Cl minus is coming. So Lee-Chatterjee's principle says, if concentration of product is increasing, then reaction will move in backward direction. Again, Cl minus is coming, then solubility of AgCl will decrease. In pure water, there is no common ion. In aqueous ammonia solution, usually this ammonia solution, if it is given or Ag with cyanide is given, they form complex with Ag, very good complex. Reaction almost move into forward direction with these two. As they are decreasing, these ammonia and cyanide, they are complexing with Ag plus, so they are decreasing the concentration of Ag plus. They are decreasing the concentration of Ag plus, so reaction will move in forward direction, hence solubility of AgCl will increase. So if we compare this, solubility in ammonia will be highest, then solubility in water, then solubility in this problem AgNO3 solution, and it will be equal to solubility in HCl solution of AgCl. In D case, ammonia is forming complex with Ag plus, as it is forming complex with cation, so cation will be removed from the equilibrium. So again salt will redissolve, its more amount will dissolve into water to furnish more number of cation. Okay. Percentage hydrolysis of this thing. This is a salt of weak acid and weak base. So for salt hydrolysis, we should be very comfortable with the formulas. This is weak acid, weak base. So for this, pH is defined as half pKw plus pK minus pKb. Very important. This is independent of concentration. It does not depend on concentration of salt. That is why it works as buffer solution. So you just need to put the value of Ka and Kb. As K and Kb are same, so their pK and pKb will also be same. So the pH will become half of pKw. Okay, pH will become half of pKw. Also, along with this, we should be aware of the formula for this hydrolysis constant is Kh, H upon 1 minus H. Kh is nothing but Kw by K into Kb. These all formula you should be aware of. So for this Kw can be calculated as this, which will be nothing but 10 raised to minus 14 and 1.8 into 10 raised to minus 5 ka square. So in this expression, if I put this value, root Kh will become 10 raised to minus 7 divided by 1.8 into 10 raised to minus 5, H by 1 minus H. You take this will be 180, 10 raised to minus 7, then it will, this is 1 by 180, H upon 1 minus H. So it will be 1 minus H, 180 H. So it is nothing but H will be 1 by 181. Into 100 if you want to calculate the percentage, they are asking about percentage. So percentage will be 100 by 181. Around 0.55. Okay. In percentage they are asking. So this is, please write this down, these formulas are very important. pH for this weak acid, weak base. Okay. Which of the following is buffer solution? So now we have covered almost all the topics. Now questions can be from buffer, salt and all. So which of the following is buffer solution? I have already told you, for to act as a buffer it should be weak acid plus its salt, weak base plus its salt, or salt of weak acid and weak base. So in this case it is weak base plus its salt. So it can act. This is also, in this case also you see, this is weak acid and its salt. All of these can work as buffer solution. So answer will be D. The best indicator. So regarding indicator also it is very important in indicator for titration curve. So I have already given this thing. For indicator, if you add something, you see these graphs are coming like this, or graphs will be coming like this. So indicator, the suitable indicator will be that which is having pH range in this region. This is steep region. So if you are, this is weak acid, weak base, if you are taking weak base and if you are adding acid, then graph will be like this. This is for acid base indicator. This is for acid base titration graph. This is for base acid titration. If you are adding base into acid. So according to the range, if you are adding strong acid into strong base, then at equivalence point this will be 7 pH. The pH will be 7. So for them any of these can be used. If it is weak base and you are adding strong acid into this, then best they are methyl orange and methyl red. If you are adding acid into base, so it will be like this. The graph is like this. So for them suitable indicator is methyl orange or methyl red. If you are adding strong base into weak acid, then they should follow this. And for them the suitable indicator is phenolphthalein. For weak acid, weak base, we do not have any suitable indicator. And for weak acid and weak base, the equivalence point is calculated using conductometry. There we do not have, because it do not give any sharp equivalence point. Okay, so we cannot get any suitable indicator for weak acid and weak base. Now coming to the question. If they are asking about weak acid and weak strong base, so weak acid is there, you are adding strong base. So weak acid, the pH will be some higher and it will increase, you are adding base. So from the next table you can see, if we take weak acid and strong base, then phenolphthalein is best indicator. Or pH of these two can be used. the best indicator for endpoint of weak acid, this is much better because it lies in this region. This will be some pH 7. So any indicator which lies in this region can act as best. So if there is no phenolphthalein, then we can also use bromothymol, but phenolphthalein will be better because it is having much closer range in the equivalence point for weak acid and strong base. Clear? Okay. Again, this is a salt of weak acid and weak base. You can use formula weak acid plus weak base. Ammonium acetate is, they are asking pH, same formula we already know pH is half pKw plus pKa minus pKb. You can use this. Ka4 and Kb, they are same. So for this pH will come as close to 7, that is pure water. These are the formula for weak acid and weak base. Very important formula. For weak acid, strong base, example is acetate ion, sodium acetate. You check as it is having two components. One is coming from weak acid, other is coming from strong base. So if any salt is given, so you see there can be two components, cation and anion. Cation will be coming from base, anion will be coming from acid. Cation will be coming from base, anion will be coming from acid. So if cation is coming from stronger base, so and anion is coming from weak acid, then we will say the salt will act as basic salt. Okay, depending on if cation is coming from base and anion is coming from acid. If cation is coming from strong base, then we will say that it can have basic nature. If anion is coming from stronger acid, then we say it is having acidic nature. If both are coming from strong part, then we will say the salt will be neutral. There are 6 strong acids which we use: HCl, HBr, HI, HNO3, HClO4 and H2SO4. If anion is coming any one of these, then it will be called as that anion is coming from strong acid. And for cations of alkali metal and alkaline earth metal, other than those, no other ions cation will be considered be coming from strong base. So strong bases are hydroxides of, in Ionic we will use hydroxides of alkali metal and alkaline earth metal except beryllium. NaOH, KOH, cations of those things. So if this is given, see this is coming from strong base, so this salt will have basic nature. If you want to remember the formula, it is very easy. Half pKw, as it is basic, so pH should be greater than 7. What I am saying, it is expected to be greater than 7, but it not necessary that it comes as greater than 7, but we are expecting to be greater than 7. So in this case, all other values will be added. If you want to remember, in acidic salt, the pH is expected to be lesser than 7. So these values are subtracted in this 7. This is a way to remember them. It is not necessary that pH will be coming than 7 or less than 7, but we know that it is basic salt. So to remember, you need to add these values. If it is acidic salt, we can subtract values because pH is expected to come less than 7, but not necessary it will come less than 7. Okay, so this is how you can remember these formulas. And also this C, what is this C? This is concentration of weak component. Weak component from weak, need to see. So if acid is given like this, CH3 COO twice Ca, if it is given 0.1. So in this case, C used will be 0.2. If I have given, okay, here I am writing. If it is given CH3 COO thrice aluminum. So if formula is pH half pKw plus pKa plus log C. So if it is given C, then here we need to put 3C. If it is twice Ca, then it will be twice CH3CO minus plus Ca plus 2. So here you need to take twice C. Very important. It is not salt, it is not concentration of salt. It is concentration of the ion which is taking part, because of which hydrolysis is going on. In anionic hydrolysis, it is concentration of anion. In cationic hydrolysis, it is concentration of cation. So in this case, this is anionic hydrolysis. So concentration of anion is twice of this. Okay. Now, coming to solubility again. For solubility, which of the following case AgCl is unsaturated? So whenever there for any salt AB, if ions are given, then you just multiply concentration of ions, and this is known as KIP. Similar to Q, reaction quotient. This is KIP, that is ionic product. So if this KIP and this KIP, it is variable, similar to Q, it is a variable. It can be calculated anytime. Anytime you can calculate it anytime. It is variable, can be calculated anytime. It is not a constant, it is a variable. Okay, and you calculate this value. If KIP is less than KSP, means solution is unsaturated. More salt can be added. If KIP is equal to KSP, it means solution is saturated. And saturated solution is known as just precipitation. Just precipitation condition. If KIP is greater than KSP, then we say supersaturated solution. Supersaturated means already PPT is formed. So in this case, they are asking AgCl is unsaturated. So whenever this is less than, it is unsaturated part. This is supersaturated. This is your KSP when it is saturated. Okay, fine. So in this problem also, if you are taking equal volume, remember what I said, whenever there is a problem where you are taking mixing, you need to account for the total volume. When you are mixing equal volumes, then total volume will change. In this case, concentration of these ions will also change because volume is getting doubled. So concentration of Ag plus will become, so in the first case we can write 10 raised to minus 4 by 2 into 10 raised to minus 4 by 2. In second case we can write 10 raised to minus 5 by 2 into 10 raised to minus 5 by 2. Because you are adding equal volumes, so concentration will become half. In third case you will write 10 raised to minus 5 by 2 into 10 raised to minus 6 by 2. In last case you can write 10 raised to minus 10 by 2 into 10 raised to minus 10 by 2. And they are asking which of the following solution mixed the precipitate of HCl. So you take any in between thing, you take in between thing, and if it is forming precipitate for this, then accordingly you can compare. So if I see for the first itself, this will become 10 raised to minus 8 by 2, that is 5 into 10 raised to minus 9, which is greater than KSP. As it is greater than KSP, so this will form PPT. So one important thing is equal volume. Whenever equal volumes are added, you need to also change the concentration and then you multiply it. Okay, moving to the next. If this is given, this is very simple, but through this we will understand again concept of solubility. Again, if this is solid, this A minus S, this S is the solubility of the salt, but on dissolving it will generate X times of S and Y times of S. So the solubility of salt, it is S. Solubility of A plus Y, it is X times of S. Solubility of A B minus X, it is Y times S. Very important. And what is this XX? It is the concentration of A plus Y in solution. This is concentration of B minus X in solution. Okay. So very important. If you put in the formula, this will be Ksp X times S to the power X y S to the power Y. So this will give X to the power X, Y to the power Y, S to the power X plus Y. General formula. Okay. So if X and Y, they are combining to give 2, then that is known as binary salt. Then tertiary salt, if they gives 3 ions, if they salt on dissociation gives 4 ions, that is quaternary salt. So binary salt will be represented like AB, A2B is tertiary salt, A3B it is quaternary salt, like that, pentenary. So this is heptenary salt. If you use the formula, then also you can say in terms of solubility Ksp. So Ksp for this you can calculate very, you give thrice of zirconium ion, 4 phosphate ion. Either you can use formula X to the power X, Y to the power Y, S to the power X plus Y. So in this case 3 to the power 3, 4 to the power 4 and S to the power X plus Y, that is 3 plus 4. So 27, it's a very big, huge number. So you can see from here, these two cannot be true. So 27 into 64 into 64, S to the power 7. It has to be C. So in this case, if they ask what is the solubility of salt, this is S only. For this solubility is S, for this solubility is 3S, for phosphate ion it is solubility is 4S. Which of the following is most soluble in water? So Ksp is given, we can calculate S for each one of them. Whichever is having highest S, it will be most soluble. So they are, if you see, one of them is pentenary salt, other is binary salt, other is quaternary salt, other is, this is again quaternary salt. There are 2 quaternary salt. If 2 salts are of same nature, both of them are same nature, then which is having higher? If salt are of same nature, means both of them are binary or quaternary or tertiary, then higher Ksp, higher solubility. So among C and D, higher solubility will be for phosphate, that is D. Among these two, and so we can calculate for this D also. For this solubility will be nothing but root of Ksp, that is root 7 into 10 raised to minus 8. This is again pentenary salt A, which shows very low value. So for D also we can calculate. For D, Ksp is nothing but X to the power X, that 3 to the power 3, and Y to the power Y, that is 1 to the power 1, into S to the power X plus Y, that is 4, 3 plus 1. So 27. So 1.8 by 27 into S to the power 4. Minus 18 S to the power 4. So if you take this, it will come as, even if I take 9.23, so S to the power 4 will be 2 by 30 into 10 raised to minus 18. Even if I write it as approximately 6.66 into 10 raised to 20. So 10 raised to minus 5, and this is 10 raised to minus 8. It will come, S will come in the range of 10 raised to minus 5. Hence D will be the most soluble. So these are some lengthy problems and given for practice only. Okay, so coming to the next problem, in which it is given in terms of, solubility is given in terms of gram per ml. So if it is given in gram per liter, so first thing is you need to convert it into mole per liter. That is important thing, otherwise answer you will get a wrong answer. So concentration, that is solubility, it can be converted by dividing by its molar mass. So if you approximately, because this value is not very good, so if you do very vague approximation, and if you even write like this 46 into 10 raised to minus 2 divided by 245, very far, that it approximately 1 by 5 into 10 raised to minus 2. I am doing this because options are which given, they are very far from each other. So if I take this as 1.1 by 5, and if I now put this PV F2, it's converting into PV plus 2 and 2F minus. So this A minus S, this S, this is 2S. So if you write its KSP, it will be 4S cube. That is 4 into 0.2 into 10 raised to minus 2 to the power cube. That is 4 into, if you write 8, 10 power minus 3 and 10 power 9. It will coming as 32 or 3.2 into 10 raised to minus 8. So most close answer is B. But the important point in this problem is that if they give you in gram per liter, you need to convert it into mole per liter. That is important part. Okay. Moving to the next question. The pH of the saturated solution of this, very important. So it is giving CuOH, Cu plus 2, 2OH minus. So if it is A, this is A minus S, this is S, this is 2S. So concentration of OH minus is 2S. And S can be calculated by KSP. So KSP will be 4S cube because it is tertiary salt. So tertiary salt, so this will be 2.6 into 10 raised to minus 19 into 4S cube. So from here you can calculate S and you can substitute and you can get value of OH minus. So it will be 0.65 into 10 raised to minus 19 or 65 into 10 raised to minus 21. That is your S cube. So S will be root 65 into 10 raised to minus 7. This is your S. If you substitute over there, it will come as 7 minus something, 7 से कम आना चाहिए. Then OH minus will come lesser than 7 and pH will be higher than 7. Okay. So root 65, if you take this, S will come as approximately 8 into 10 raised to minus 7. So this OH minus will come 16 into 10 raised to minus 7. Okay. So the POH will come as 7 minus 4 log 2. So 7 minus 0.3, 1.2, that is 5.8. So pH will be, if you see pH, that is 14 minus 5.8. So something 8 point something आना चाहिए. Okay, I have done some approximation, that is why those values are not matching. Okay, moving to the next. So important point is that this indicates, this 2S indicates total concentration of OH minus. Okay, so for this problem they have given what is the molar solubility of Fe hydroxide at pH this. So they have given you pH. It's a good problem. So it will be A minus S, S, 2S. But we have maintained this is a solution in which ferrous hydroxide is present, but somehow we have maintained the pH also. So there is some external source from where OH minus is coming. This is not the only source. Ferrous hydroxide is not the only source, somewhere else also it is coming. So concentration of OH minus will be 2S plus something, some other concentration, and it is given as according to pH, pH is 13, so POH is 1, and so that means OH minus is 10 raised to minus 1, that is 0.1. So it is given as 0.1. So in the expression of KSP, it is Fe plus 2 and OH minus chi square. This concentration of OH minus is given as 0.1. So it will come as KSP is 8 into 10 raised to minus 16. This is S and this is 0.1 chi square. So S will come as 8 into 10 raised to minus 14. And they are asking the solubility of salt, and solubility of salt is always S. So the correct answer will be D. Solubility of Hg2I2. So this is given, this problem is important because this salt, it does not break like this to Hg plus, it does not break like this, it does not dissociate like this. This salt of Hg plus always they break so Ksp for this will be cation into I minus K square. So these, it is because Hg plus is larger in size, so its van der Waals force is very high, so another Hg plus they combine together due to van der Waals force and they exist in a solution as a single entity. So whenever there is Hg plus, it does not, in solution it does not appear as Hg plus, it will always appear as Hg2 plus 2. So this is not quaternary salt or ternary salt, it is tertiary salt. It is tertiary salt. Okay. Then there is one important thing regarding to salt analysis. They will give you some 3-4 salts and they will even not give you the Ksp value. If Ksp value is given, then we can compare. If Ksp value is not given and some random salts are given, they will not be random, they will be from salt analysis. So if some salts are given like this, so we know already that these salts of alkali and alkyl metal, they are highly soluble. They will be highly soluble, so they will be having better solubility. Other salt from D block, then we need to check their grouping. This grouping is given in NCERT. So if they belongs to group 2, their sulfides are having low solubility as compared to sulfides from 4th group. So group 2 salts are having lesser solubility than group 4. That is important point. And in NCERT they have given only 3 salts as group 2. In group 2 there are other salts, bismuth salt, cadmium salt. If they give from group 2, only 2-3 salts are giving from group 2, then they will give you Ksp value. Without Ksp value, it means one of the salt will be from group 2, other will be from group 4. So group 2 salts, they are having lesser solubility, that is why they are precipitated first in presence of HCl due to common ion. In the lesser concentration of sulfide ion, they get precipitated. So if some random salts are given, so this one is given CuS, other ZnS. So you check, Cu belongs to group 2 and Zn belongs to group 4. So group 2 salts, group 2 sulfide salts have lesser solubility than group 4 sulfide salt, and this is applicable for Ksp. Ksp of group 2 is lesser, or not Ksp, we say solubility. Better word will be solubility. And this will be compared, their solubility of group 2 sulfide salts, sulfide, not sulfide, this is sulfide. Sulfide salt of group 2, they are having lesser solubility than group 4. So Na2S will be having highest solubility, then group 4, then group 2. Okay. So that is all in ionic equilibrium. I tried to cover each and every topic of ionic equilibrium extensively. Okay. Thank you so much. All the best.